Hey Algebra 2 students, welcome back. Today we're looking at solving systems by graphing. So if you're to draw two lines, there's three things that could occur. One, you could have parallel lines. So if we look at this example, parallel lines mean that they could go on forever and never intersect. The second case is if we have one intersection point. So you can see the point where the two lines cross. And then the third case would be if we have overlapping lines. So what happened here is it's hard to see because it's just one line, but both lines overlap each other, which means that all the points that are common to both lines are going to be solutions. All right, so let's talk about how to classify these, because that's the first part of your assignment for today. So if you have parallel lines, then we have no solution, because there's no place where our lines are going to cross. They're not going to intersect at all. And this would be an inconsistent system. Okay, in the second case, if we have an intersection point, then we're going to have one solution, which is at the point. And this one is called independent solution. Oh, sorry. Independent consistent solution. Okay, just some terms that they're going to ask you about. And then the last one, if they're overlapping, this one has infinitely many solutions. That's because any point that lies on the lines is going to be a solution for our system. And then this one would be consistent dependent. Okay, so just classifying, whenever we have our parallel lines, there's going to be no solution and it's going to be an inconsistent system. If we have one intersection point, that's one solution, and in a consistent independent or independent consistent system, and if the two lines overlap, there will be infinitely many solutions, and that's a consistent dependent system. Okay, so let's solve these by graphing. We're going to use Desmos, but you have your graphing calculator stuff in your Alex, so you can do it in Alex. If you feel more comfortable doing it in Desmos, that's fine as well. So let's go ahead and graph the first one. Y equals negative 3x minus 5 and negative 10x minus 9. So y equals negative 3x minus 5. And we'll do another one here. Whoops. Y equals negative 10x minus 9. Okay, so if we look at these two lines and we find the point that they intersect, it's at negative 0.571 and negative 3.826. I think the Alex assignment is asking us to round to the nearest hundred, so that would be 0.57. And we're going to have to round the 8 up to 9, so negative 3.29. Okay, so pretty simple. Graphing is probably the easiest method to solve systems if you have graphing technology to use. So substitution and elimination are great to do if you want to do it algebraically, but if you want to just find an answer and you have graphing technology, it's probably the easiest way. Okay, so the second one, be careful here because the top one is not in slope-intercept form, so we're going to convert to slope-intercept form. So let's go ahead and move this 2x away from our y. So that's going to be 0. Y is equal to 2x plus 6. And we don't have a coefficient in front of our y, so it makes it easier. Just remember, if we did have a coefficient in front of our y, that we need to divide by that coefficient. Some people made that mistake on their last exam, so just make sure that we get it into slope-intercept form properly before we start graphing. So we're going to go ahead and graph this one and the one we converted. So we have 2x plus 6 y equals 2x plus 6, and then we have y equals negative 1/3 x minus 1. Oops, I forgot my x in the top. There we go. So you can see that this one, our intersection point, is an integer, or our integers for our coefficients are our coordinates. So the solution to this one is negative 3 and 0. Okay, so pretty straightforward, nice and easy because we have the graphing software. So just make sure if you need to convert to slope-intercept form that you do so before you graph. Technically, I think Desmos might graph it in standard form, but I'm not sure if it will in Alex. So it is good habit to be able to convert. So we'll work on converting before we put it in. Okay, I think that is it for today. Good job, and I'll see you guys next time.